Welcome everyone, my name is Subhasagar Mahestakar. My college ID is 240118 and my Coventry ID is 153696769. This Viva presentation is a part of assignment called Intelligent Information Retrieval. The assignment is divided into two parts. The task 1 is to create a vertical search engine, while task 2 will do some clustering. Let's explain the task 1. For task 1, we'll need to scrap data from pure portal website of Coventry University. As you can see in the code, we are scraping the data from this website. After the data, the scrap data contains publication title, authors, publication year, and publication link. The scrap data are then stored to a JSON file. I have named the JSON file as research.1.json. After the data are scrapped, we now move on to the search engine part. For the search engine, it is similar to a Google Scholar search engine, where a user will provide a query and the query will be then tokenized, streamed to the root form, and the stopover are removed. Then we will examine the query and calculate its cosine similarity to find the relevant score. The relevant score is used to extract a suitable data from the document we have stored in the research.json file. Let's see how the code works. Here is the home page of our search engine. As you can see, we have a dialog box to input our query. Let's put a query and check the result. As you can see, we have got different results from the input from the query we have given, and we can see that the documents are sorted on the basis of relevant score, and if a better query is provided, then we can see the relevant score also increases. We can also access the article directly from the search engine, as well as we can get access to the author's page as well. Now, for the next part, we'll move on to the clustering part, which is task 2 of our assignment. For this task, we have collected news data from various websites like BBC and CNN. For this task, same as task 1, we'll take a query from the user, and then the query will be tokenized, then changed to root form using steamer. After the stopovers are removed, we will then calculate the Silote score using k-means. This score is useful to measure how suitable our clustering is. After we cluster our news data into 3 categories, namely politics, entertainment, and economy, we can check the cluster of the new data provided by the user. Again, let's see how this code works. Here you can see a dialog box similar to our search engine. We can provide a cluster, we can provide a query in this dialog box, so we can put it in a suitable cluster. We can take news data from any website. As you can see, the results show economic category, which is correct. Let's try another. As you can see, the again our cluster is correct. We can check various clustering. The basic principle of this clustering is to take the news data we have collected to train our model, and after that we can check the cluster of any model we have provided. And this concludes my presentation. Thank you.